We've all seen flying saucers and UFOs in videos from Hollywood or from other sources. While science fiction can be fun, it's more interesting to consider the science of the situation. Is it physically possible for objects to hover and levitate like a flying saucer does in the movies? In the next few minutes, I hope to convince you that not only is it possible to levitate something using scientific principles and facts, but it's used regularly in children's toys within the marketplace. Let's begin.
Introducing the Levitron. Simply spin the top on the plate and gently lift, and voila! The top is levitating. The top resembles a flying saucer, doesn't it? Just to make it clear that there's no Hollywood effects being used in this video, I'm going to pass my hand below, above, to either side, behind, and in front of the levitating top to show that there's no glass or strings holding it up. Now that we've established that the top does levitate, let's have a look at how it levitates.
Here we have two bar magnets. One of the main characteristics of bar magnets are their north and south poles. In these two magnets we have the south poles indicated in red and the north poles indicated in blue. When two north poles are brought close together, they repel. When two south poles are brought close together, they also repel. But when a north and a south pole are brought close together, they attract.
The Levitron's top is also a magnet. You can see it right here. It's the little shiny metal piece there, with one of its poles pointing outward along the part that you grasp to spin it, and the other pole pointing downward out through the nubby bit that it spins on. There's a second magnet in the base of the Levitron. It's a donut-shaped magnet, which I'm attempting to outline for you right here. This is the outer edge of the donut magnet, and the inner edge is right here. The shaded region is all magnet. There are, of course, two poles to the magnet. One of the poles is facing out of your computer screen and one of it into the computer screen, or one out of the Levitron and one down into the table. Here's a second ring magnet I happen to have lying around the house, just to give you guys an idea of what the magnet in the base of the Levitron might look like. As you can imagine, to create the levitation effect we see in the Levitron, one must cancel out the force of gravity. To do this, magnets are used. The magnet in the top and the base are aligned so that the like poles, either north and north or south and south, are facing each other, thus repelling and creating a force exactly opposite to that of gravity. It's also important to note that magnets attract much more strongly and repel much more strongly when they're close together. Thus, when the top is spinning above the center of the donut-shaped magnet, it's a little bit further away from the donut-shaped magnet than it would be if it moved a little bit to the left or a little bit to the right, since it doesn't move up or down very much. Thus, if it does move a little bit to the left, right, forward, or backward, it'll be pushed back to equilibrium in the center. If you've ever played with magnets before, you might be wondering how I'm keeping the magnetic top from flipping over and crashing into the base of the Levitron. The answer to this is a concept called angular momentum. Before getting into a discussion about angular momentum, though, it's important to understand what linear momentum is, and that'll be the next topic we cover. At the heart of the concept of linear momentum is the idea that if an object is moving, it will continue to move unless acted upon by an outside force of some sort, be it gravity rubbing against something, interacting with a magnetic field, or perhaps a collision with another object. And if an object is at rest, it will continue to be at rest unless, again, acted upon by an outside force like gravity, a magnetic field, collision, or rubbing against something. This concept is perhaps best exemplified by a pair of pool balls. If you take one pool ball and give it an initial speed and leave another pool ball at rest, aim the first pool ball that's moving at the pool ball that's at rest. Both balls will either move or stay put, respectively, until they collide, at which point one pool ball will move off in one direction and the other in the other direction, both with different speeds than they had initially. Similar to the concept of linear momentum is the concept of angular momentum. This idea is perhaps best exemplified with a demonstration with a gyroscope. This is a gyroscope. You can see the large red plastic frame that holds the gyroscope right here. I'll outline that in blue. This is basically just to hold the gyroscope in place and to keep it from spinning out of control if it falls over. The main part of the gyroscope is the metal disc right here. You can see it's a little bit of a brassy color. It's very heavy and it gets spun at a very high speed by putting a string through this little hole right here and then wrapping it all around the post here. Then the string is pulled out and you get a high-speed gyroscope spin. As you can see, I've just given the gyroscope a little spin and I'm setting it down on the table right there. And what do you know? It stays upright. This is because of the properties of rotational inertia. The idea of rotational inertia is, like the way linear inertia or linear momentum will keep an object moving in a straight line, when you spin an object, it will keep on spinning on the same axis as you spun it on. So, the axis of rotation, about which the top is spinning, is right along the black bar in the middle of the gyroscope. And, as you can see, it more or less stays straight up and down. If you've ever ridden a bike before, you may have noticed that after the first few pedals it becomes much easier to keep the bike straight. This is because the rotational inertia of the tires is helping to keep you going in a straight line. And there we have it. Rotational inertia has been the invisible force keeping the top upright and not flipping over in the magnetic field of the Levitron. So while flying saucers remain in the realm of science fiction, through the power of angular momentum and magnetic fields, the Levitron manages to defy gravity. Who knows what the future may bring? Perhaps a person just like you will develop technology based on these concepts to take humanity to the stars.